Good morning, good afternoon, and good evening, depending on when you're joining us from. Welcome to our webinar, which is part of the Early Webinar Series of 2025. Thank you for joining us, and I hope that you will enjoy and learn from our webinar, which is titled Diagnosis and Physical Audit of Boreholes and Pumps, Striving for Accountability. My name is Fadzai Mnodawafa, and I'm a Zimbabwean, and I work as a consultant with Hydrologica. I'll be the moderator for today's webinar. So for our agenda, the very first bit is the welcoming, which we have just done, and we will have the setting of the scene. We will have two presenters, that is Muti Nhlema and Nick Mannix. And then we're going to move on to the third part, which would be borehole infrastructure diagnostic methods, an approach to hand pump investigation and rehabilitation, presentation that will be done by Steve Kumwenda, who's with BASEflow. The fourth part of our agenda is a discussion and Q&A session that will have panelists, and we'll have Marcela Lopez from Water Integrity Network, Ayabale Aret from World Hunger Hilfe, and Jennifer from the World Health Organization. Lastly, we're going to have our closing remarks. So for this segment, I would like to welcome Muti Nhlema, who is a team leader of BASEflow and an award-winning multi-Malawian-run social enterprise, which is working to improve the sustainability of groundwater resources for rural populations to access safe drinking water. And we also welcome Nick, who is a chartered hydrogeologist with over 10 years professional experience working on groundwater supply and management projects. Welcome, Nick and Muti. So just to set the scene before this webinar, can you please tell us about your experiences on relating borehole and pump diagnostics to accountability?
Yeah, thank you for that. Yeah. We thought we would start by just giving a bit of a background to what's going to be discussed today, because the work that Steve's going to be going through in the main part of the webinar has its roots going back, I guess, almost 10 years now, where myself, Muti, Steve, and many others worked on a Scottish government-funded programme, which was called the Climate Justice Water Futures Programme, where we were looking in detail at water point functionality in Malawi, particularly in the context of persistently high levels of poor functionality that were observed. And even at that point, sort of 10 plus years ago, there was a growing amount of sort of anecdotal evidence and awareness that in many cases, functionality issues were persistent and didn't seem to be able to be solved through community-based management approaches, even with lots of borehole mechanics and training and spare parts. And this pointed to the fact that there were, in many cases, deeper issues with water points, indicating that borehole installation and water resources were often not fit for purpose from the start. And the water point, which was supposed to be an asset, potentially ended up being a burden for communities in many cases. So these findings were largely anecdotal from the start. And through the CJF program, we thought it was a good idea to look deeper at this and gather sort of primary information on this to understand the root causes. So we developed a methodology termed borehole forensics, which was a method for completing a full sort of deconstruction and forensic type assessment of a water point, which I think is what Steve is going to be talking about in detail. And using this methodology, we were able to sort of shed light on out-of-sight aspects of the water point, such as the borehole construction and the nature of the water resource. And we found that in many cases, this functionality issues were associated with sort of insufficient care and attention during the original lifespan, during the original installation of the water point, leading to persistent poor functionality through its lifespan. So these findings led into sort of a lively conversation and debate in Malawi around accountability and how to address these issues. And think it's probably a good point to pass on to Muti, because he likes the lively debate and has been involved in a lot of these conversations in Malawi.
Yeah, yeah, you give me the lively, difficult part. Thanks, Nick. I can't believe it's already been 10 years. And yeah, as Nick has rightly said, at the time, there was a lot of anecdotal evidence of the failure rate that was there. 25 to 30% of the boreholes in my country, Malawi, were failing. And a lot of the time, the blame was put on communities, that you're not fixing them, you're not doing what we taught you to do. So we thought, is it really communities? So the borehole forensics, or the diagnostic approach that we learned from the Climate Justice Water Futures program, which the borehole forensics is something that we've kept going for the last 10 years. And in that time, we've actually conducted about 450 borehole forensics assessments on 450 sites across Malawi. And so we do have a very interesting picture of what's going on. I mean, one piece of data I can share is that 1 in 5 of the wells that we've surveyed failed the pumping test, meaning that they're not able to even meet the minimum standard of yield for people to actually use. These locations should not have been commissioned to begin with. So as an organization, as much as we had all this data, the question was, what do we do with it? And I think I'll be a bit biased here because I'm the theme lead for Data for Action. So I love having data, but I always ask, what do we do with it? And this was the question that we asked ourselves at BASEflow. And because with the data, we knew what the problem was, we knew who put the wells there, and we asked ourselves, could we hold them accountable? So this was the question that we were trying to answer to address the stranded assets, the failed water supply infrastructure that was across the country. So this was really looking at moving from the technical to the social, in essence. So moving from what is more technical in terms of the forensics and looking at how we can use the technical to address the issues of accountability. But we realized as we were making that transition from the technical to issues of accountability, we're moving from what was simple to complex, what was tame to something that was more wicked in nature. Because I'll not go into too much detail here, but our experience has shown that the challenges that are causing this failure rate that we are seeing are actually as a result of a minefield of perverse and unchallenged incentives. So when we were going into the accountability work, we had a lot of assumptions. And one of the assumptions was that the problem is the driller. The driller is the one who should be held accountable. But after the work that we've done, and we'll talk about this a bit more after Steve's presentation, it may not be that simple. There are lots of incentives that drive drillers to do the things that they do. And yes, drillers themselves are to be held accountable. But we're finding that in some cases, it's the contracts that drillers sign with NGOs that cause them to behave the way they behave by not following standards. In some cases, there's a lack of supervision and regulation to the point that in some cases, drillers don't even submit a drilling report that we can use to compare what they found when they drilled with what we found when we did the forensics. So we're finding that it's a lot more complex than we actually thought. And last point, very often we think that the stakeholders in groundwater development are just NGOs, government, and drilling companies. In our work, we've discovered that there are other stakeholders that are in the space that are doing groundwater development. And in some cases, that groundwater development is not following standards, but they're not being held accountable. And one stakeholder group that we've discovered in the Malawian context is faith-based organizations, both Christian and Muslim, that are providing a much needed service, but not following the standard. And we have found that in some cases, the stakeholders who can hold them accountable don't want to do that. So it's a very interesting minefield of perverse and unchallenged incentives that are producing the results that we're seeing. But we'll get into more detail, I think, during the discussion phase of this particular webinar. So that's been our experience, taking the technical into the social political and how it moves from simple to complex. Thank you.
Wow, thank you very much. That's very interesting. So I'm just learning that we could never really separate these two. When we do the technical, we also need to look into the accountability issues when it comes to boreholes. So thank you very much, Nick and Muti, for this interesting conversation. We're going to be hearing from you later. But for now, we want to move on to in the next segment, which is a presentation from Steve. A warm welcome to you, Steve, who is a program manager also with BASEflow, and he'll take us through what borehole diagnostics are and what has been learned in Malawi from actually doing these. Over to you, Steve.
Hello, a good morning and a good afternoon, depending from wherever you are. Welcome to this presentation on diagnosis and physical audit of boreholes and pumps, striving for accountability. My name is Steve Kumwena. I'm the Water Resources Program Manager at BASEflow in Malawi. In this presentation, I'll introduce what borehole and hand pump diagnosis is all about, then talk about the 9 methodological steps in borehole diagnostic methods. We'll look at the key borehole diagnostic findings and also touch a little bit on borehole rehabilitation, and then we'll share on the way forward for this work. As you might appreciate, there is need to reverse the poor performance trends of hand pumps. According to our findings on borehole forensics in Malawi, 30% of boreholes fail within 5 years of installation. Hence, the need for detailed diagnosis of borehole and hand pumps performance. So this is a step-by-step guide through a series of field tests and investigations that you collect data. The test results are required to identify consistent problems with water point infrastructure, and then findings are critical for remedy and decision making, either to repair a borehole or rehabilitate. And also, bigger decisions could also be made, particularly on policy and standard operating procedures that affect operations and maintenance. Also, you have to be using a sort of data collection tool so that you are able to collect and document the data for records keeping. M-Water has been used in most of our cases to collect and analyze the data. Now I'll begin delving into the 9 steps in borehole diagnostic methods, and I plead that you be awake and be with me as I go through these steps. So the first step is definitely you have to visit the water point, the infrastructure. So during this initial visit, you engage with a community or a committee, introduce yourself, who you are, what you're going to do, and also gain permission or some consent of some kind so that you're allowed to work on the borehole. Then locate the site by mapping. You can either use any management information system or GIS tools so that you're able to take the coordinates and be able to map the location. Check the possible contamination sites surrounding the water point. You should inspect at least 100 meters radius of any contamination sources, could be pit latrines or graveyards and so forth. And then also assess the general AfriDep condition, or it could be any other pump condition, just looking at the functionality, the age, and also the depth. Some of this information at this point, you can get it from the community members around the water point. And then move to step number 2, where you can start inspecting and also conducting some tests. You can photograph the site before the actual works start. Then you inspect the water point head, that is the pump head. You can also check if there are any surface water flows, either streams or rivers, close in close proximity to the borehole. And also you begin to conduct some on-site chemistry water quality tests. These could be electrical conductivity tests, TDS tests, and also conducting the pump efficiency or bucket test. This is where you want to check if there are any leakages in the pumping system, and also if the discharge is according to how the pump performance should be. This helps to detect early issues before you just dismantle the borehole, so that you can actually be informed that perhaps we could meet certain kinds of problems due to leakage or discharge of the effect of the pump. And then moving on to step number 3, this is now actually physical work that demands that you dismantle the hand pump. And before you begin to do this, ensure the safety of each member participating in this exercise. Ensure that every member has put on personal protective equipment, so that there's no risk of accidents, and also safety is ensured around the place. And then you remove the outer parts of the pump. The inner parts should also be removed, including the rising main pipes. And if this has been achieved, the hand pump has been removed, it means now you begin to deal with the borehole, which can be inspected. Getting into step number 4, you need to have the measurement tools ready so that you record the height of the pedestal, as well as the horizontal and the vertical levelness of the pedestal. Checking verticality using a builder's level helps to determine if this pedestal is straight. And if it's not straight, this has issues always with the performance of the hand pump. Also measure the water level in the borehole. Since the borehole has been opened and the water has rested, you get the static water level reading just to see how deep underground the water is. And then calculate the borehole depth in meters below ground level, so that you ascertain the depth of the borehole. Now you get into step number 5, which is a very critical part of the diagnostic process, where you conduct a camera survey using a borehole camera to inspect the inside of the borehole. A borehole camera is a device which has a camera and also a long cable that is lowered into a borehole, so that you can actually get readings at the depth in meters, as well as the picture, the visuals, which are able to be saved, or pictures are able to be taken. The purpose is to actually view the condition of the inside of the borehole and identify any issues which are visually apparent. So you'd be able to check for blockages, check the depth of the borehole, the casing's quality, how the joints are actually done, and also the type of casings, the position of where the blanks and the slotted casings are positioned, as well as extent of siltation inside the borehole. The borehole camera should be able to capture that. It also enhances part of accountability, where you can validate some of the drilling reports that you are shared by the contractor, where maybe you check the borehole depth. On the right diagram there, we're able to illustrate what we were shared with a drilling contractor from a certain project and what we actually surveyed with the borehole camera. There were quite conflicting findings. As you can see on the left there, the driller's report indicate that slotted casing were at position number 10.7, whilst what we got, the slotted casing started at 17.5 from the borehole camera. And it actually indicated that there were 2 positions where there were slotted casings. But when we checked with the borehole camera, it was only once, from 17.5 to 26.1. So literally, this report, it means that it was not true. So this was one way the borehole camera actually revealed that what was shared by the contractor was not correct. So there are a lot of issues that you can actually investigate inside the borehole that may help you to check on the functionality of the well. On this slide, I just want you to see some of the observations that we have come across during the camera survey. You could see the first picture there on top. Those are jointed casings which are wrongly jointed, and then some of the things that are falling in boreholes which potentially could contaminate the water. Things like lizards, cockroaches. So these are some of the things that would make you to say we need to actually remedy on this borehole by either maybe cleaning it or blowing it. Another critical step in the diagnostic process is to conduct a verticality survey. This is to check the straightness of the hole. The purpose is to really see if the borehole is straight enough that it can allow the pump pads to function efficiently without rubbing or causing friction with the hole, the casings itself. So there is a recommended verticality ratio, that is, you're allowed to deviate when drilling. So this is basically you should be able to deviate by 1 meter if you're drilling up to 300 meters depth. But what we have seen, some of our findings, is that a borehole of 45 meters depth, you find that it has deviated already with around 1.5 meters from the center. And this causes real problems for communities in terms of the parts wearing out faster and to be replaced. Pumping test is the 7th step in the diagnostic process, where you need to check the yield of the borehole if it is suitable for hand pumping. This is a major part of the process of diagnostics, as you should be able to test the yield for hand pumps at the rate of 0.25 liters per second for a period of 4 hours. This is for hand pumps. Generally, if it's for other types of pumping, mechanized pumping, it should take longer, 12 hours or 24 hours, depending on the need that is designed, the borehole is designed for. So you complete the pumping test using submersible pump and all the associated pumping test apparatus, as well as check the borehole if it's able to sustainably pass the yield of 0.25 liters per second. We have observed that some boreholes actually fail even within 30 minutes of pumping, and these are boreholes with low yield, and they literally cause challenges in terms of water access in communities. So during pumping test, you measure the discharge and the water level response, as well as record the pumping test data, which is the critical part, that you record the data correctly. And this data is very important. You can use it for accountability purposes to say how was this borehole actually passed when it has failed the test of pumping as per the recorded data. Now, the last but one, step number 8, is to assess and score the hand pump parts and the civil works around the water points. The purpose is to actually determine which parts that may need replacement or repairing, and rehabilitating the borehole completely. So this is a process where, as the pumping test is going on in progress during the 4 hours, you can do the grading system of the pump parts and the civil works that are on the borehole. So the scoring goes in this way, that if you observe that the pump part is missing, possibly if a centralizers are missing from the pump which was installed in the borehole, you score a 0 for centralizers. If you find that they're almost new, then you score them 1. If they're moderately aware that they can still be replaced and used again, you can score them a 3. If they're completely worn out, they're broken, okay, that they'll need replacement differently, then you score them a 5. So this process helps you to say which parts will need to be replaced, or entirely the whole borehole parts need to be replaced, need to be rehabilitated. So this scoring part is critical also to determine the remedy, the action you want to take after you've done the investigation. Now we have reached step number 9, which is the last step in the borehole and hand pump diagnostic methods. I must commend you for hanging on with me to this far. However, this is the last number 9 slide, where you reassemble the hand pump parts, and at this stage you are rectifying the identifiable issues, the worn out parts that need to be replaced. And also, once the installation is done, you should conduct the bucket test to check the improvements in efficiency or functionality of the pump. And also, you need to disinfect the borehole with a determined chlorine dosage, since the pump parts were taken outside them and there might be potential contamination. Also, you need to check if there are potential groundwater contamination sites. This was perhaps checked earlier on when visiting the site, so that you advise the community for removal or decommissioning of such potential contamination sites. And also advise the community on basic community management level of operations and maintenance, just to help them maybe the schedules for maintenance, what needs to be checked after certain intervals. Then you need to produce a detailed report with recommendations on the actions that are based on the findings that you have done through the diagnostic process. So at this point, it means you have concluded the borehole and hand pump diagnostic methods. Now, from the diagnostic method steps, allow me to share with you some of the key borehole diagnostic findings that I've come across. Generally, we have found unsuitable well designs and poor construction, e.g., for example, manually milled casings, borehole verticality issues, the straightness of the borehole, and very shallow depths of some boreholes. Low yielding of boreholes against required standard rate, yield rate. These could be due to poor siting and also poor hydrogeological understanding of the area. Corrosiveness of AFRIDEF pump parts, mainly due to high EC salinity. We have seen these mostly in the outer pump parts of the AFRIDEF pump. However, the stainless steel rods and the PVC pipes don't get much affected. But generally, most borehole pump parts issues are a result of a lack of scheduled operations and maintenance at a community level, or as well as the sector players at district or central level. Now, at this juncture, we'll take a small break from my presentation, and then we'll have some 2 questions that we'll answer, and then we'll get back to my presentation with just 2 more slides to conclude on borehole rehabilitation processes and the way forward. So over to you, Fadzai, to just take us through the questions that we'd like to attempt.
Thank you very much, Steve. That was a detailed technical approach to borehole diagnosis. Now, before we get to Steve's second part of the presentation, would like to hear from our participants and what they think about these aspects of borehole diagnosis. So we have a poll with 2 questions that will pop up on your screen. The very first question is detailing that if you were to find that India Mark II parts have corroded, what should be done to remedy this problem? The first response is nothing. Second response, put the corroded parts back into the borehole. Thirdly, change the corroded parts, replacing the few corroding pipes and rods that have corroded with stainless steel, and potentially have a mix of materials on the pump. Fourthly, check to see whether the corroding pipes or rods are galvanized iron, and if so, replace all of them with alternatives that do not rapidly corrode. For example, UPVC with stainless steel couplers or good quality stainless steel. And the last response we have is combine this information with that from other sites and use it to advocate for changes in policy and practice. So choose a response that you would think would best suit this question. And we also then have the second question. So the screen will have 2 questions, and if you can't seem to see the second question, please do scroll down and you'll see it. Question number 2, if you were to find unsustainable well construction when undertaking diagnosis, what do you think could have caused this? Firstly, you have no idea. Secondly, this may may have been a siting problem. Thirdly, the boreholes may have been designed at a desk with the design not updated in the field. The fourth response, corruption. The contractor may not have been paid properly for the work to be done and cut corners. The next response, skills problem. The driller and/or the supervisor that did not have the knowledge or experience to adhere to the designs. And our last response, the funding agency may not have allowed sufficient funds to be spent on a good quality borehole design. So we'll wait for you to vote and put in the responses that who you think would best suit these questions, and we'll be able to find out the results of the poll in a few minutes. All right. Thank you very much for taking time to respond to the questions. So we have very interesting results here, where 67% talk about checking to see whether corroding pipes or rods are galvanized iron, and if so, replace all of them with alternatives that do not rapidly corrode. So Muti, what do you think about these interesting results?
Yeah, I'm sure people didn't expect to have an exam in the middle of a webinar. So it's actually, it's good that hopefully people paid attention. And actually, I'm very happy with the result. I'm happy that I think only one person said nothing. But the vast majority, 2/3 of respondents actually chose, I think it's, check to see whether corroding pipes or rods are galvanized iron, which is very interesting because I think in our colleagues in Zambia, I think this was the NGO Wash Forum in Zambia, some of the findings that they've found there through the work with Stop the Rot has actually suggested this particular point, that it's really looking at replacing these galvanized iron parts with parts that last a little longer, whether it's PVC, HDPE, and so on. So it's interesting. I'm actually happy with this result because this is the growing consensus on the continent. And Zambia, a recent example, that this is where we should actually go. So I'm actually really happy with the result. I think the other one is not necessarily. It's interesting because I think one of the things we are trying to avoid is mixing different parts within the same water point. We usually try as much as possible to have the same kind of material. But I think generally the general consensus, the 2/3 consensus here is actually the general practice that's going on the continent. So yay! Happy to see that people are actually moving in that direction. So yeah, So that's what I would say to that. Yeah.
Okay. So moving on to the second question, which speaks to well construction. It looks like quite the majority, 58%, think it's a skills problem where the driller or the supervisor did not have adequate knowledge or experience to actually adhere to the designs. What do you think about this, Muti?
Yeah, I think this goes back to, something I hinted at the beginning of the webinar, the idea that once you move from the technical to issues of accountability, you encounter these kinds of issues. Yeah, skills is a major problem when it comes to the subject of sustainable groundwater supply, especially through the infrastructure that's out there. Some of this is a skills problem. I will use Malawi as an example. It's different across the world. You have a lot of drillers who go into the field, and a lot of the time, yes, it is a skills problem where they don't actually know what to do. For them, it's just punch a hole in the ground, and that's it. But it's actually a very, very technical, a very step-by-step process that you need to follow. And again, like I said at the beginning, drillers, yes, have an ounce of accountability, but there's also a problem with supervision. In Malawi, it is very, very common that wells are drilled without any supervision whatsoever. Zero. We've had the experience where drillers, we were supervising a drilling company. I'll not mention who, but basically what this drilling company did, they would deliberately go to the site early while we were not there to make sure that they cut corners and drilled and then disappeared afterwards. And one of the reasons they did that was they hated the idea of being supervised because it is something that just doesn't happen. And even when supervision does happen, very often it may be a local government or local municipality staff who doesn't have the skill, who's not been trained in what does it take to supervise a borehole drilling exercise. So yeah, skills is a major problem. But also there are also other elements. Corruption is a major problem. I think when we get to the discussants, probably they'll touch on this subject, where drillers actually are sometimes forced to give kickbacks so that they can get a contract. And because they get those kickbacks, they don't have enough money to actually do the job. So they cut corners and the construction is poor. So corruption does play a part in this. And usually it's corruption where the NGO is wanting a kickback from the driller. And of course, yes, funding agencies, because the cost of drilling is quite expensive. But very often we want to pay it cheap. And you pay, if you want a cheap well, you will get a cheap product. You get what you pay for. So very often we say we don't want to pay more than this. And then fine, that's what you're going to get. So as much as skills is an important component, corruption and funding that is there also play a part to produce bad construction. So yeah, and siting, yes, siting can lead to that, but siting usually that impacts on the water resource access or quantity. But when it comes to construction, it's a lot to do with these other three elements, looking at corruption, skills, and funding. People think it's cheap to drill a well. So these also contribute quite significantly to poor construction. Yeah.
Thank you very much for that, Muti. A famous saying says, a borehole is not just a hole in the ground. There's much more that's involved. And just appreciate how you mentioned that it's not just one problem. We've got many factors that really affect well construction. So thank you very much for that.
And if I could just add one last point, Fatsai. The one thing, and of course Steve is going to jump into this now, there comes a point when you can't rectify the problem. So that's something that people need to understand. If you get it right the first time as you are going through the construction process, you don't have these knock-on effects further down the line. If you don't get it right at the beginning, you can't. Sometimes there comes a point where you cannot rectify the problem with the well. So I just wanted to add that particular point. Thank you.
Thank you very much, Muti. Very wise words from you. So we're going to move on to the second part of Steve's presentation. So over to you, Steve.
Now, welcome to the final part of my presentation, where I'll talk about borehole rehabilitation, which is mostly an application of the diagnostic method steps. But borehole rehabilitation is the process of actually restoring or improving the functionality of an existing borehole, which has become less efficient and effective over time. You're actually trying to bring it to life. So the processes involve a series of steps which we have talked about essentially in the borehole diagnostic process, but you may add others like cleaning, removing debris, some sediments, and also you can do redevelopment, that is blowing, or conduct the pumping test. And also you need to improve the civil works and some structure repairs so that you first lift the borehole and the pump pads, how they actually look. Also, you enhance the sanitary seals and wellhead protection. And also, you should consider a full water quality testing so that you determine the quality of the water. And if there are issues with water quality, you have to do some chemical or microbiological treatments to the water. And finally, on the way forward, with the previous work experiences we have had with the Waterloo Foundation, BGS, Ask for Water Limited, and SCAT Foundation, and also with funding from Waterloo Foundation, we actually aim to publish a systematic and practical guide, a manual for hand pump borehole diagnostics. So we see this that it will help in having a standardized approach to troubleshooting of borehole and hand pump issues. This will help also in consistent data collection, as well as documenting some of the best practices and issues that affect borehole infrastructure. So currently we are still conducting final consultations, and very soon we begin the process of actualizing the documentation and publication process of the diagnostic manual. And once we have it as a draft, we'll have to pilot it with a few institutions, and BASEflow is already available to undertake the piloting of the diagnostic manual. We also request other institutions which are willing and available to undertake the pilot of the manual reach out to us so that we can discuss. And then after the piloting, we'll be able to incorporate the needed practical improvements and lessons that will be learned. And thereafter, the diagnostic manual will be published, then disseminated or shared across the sector for wider use. So this is how we plan to move forward. And reaching this, thank you so much for your attention and being there throughout this presentation. Now,
Thank you once again. Thank you once again, Steve, for that bit of the presentation where we are learning about the way forward. So we're going to move on to the next segment of our agenda within the webinar. And we are going to have our discussion panelists. But before that, I'll just want to remind people to send their questions in the Q&A box. You can send them in your preferred language, and we'll be trying as much as possible to answer all these questions. But if they are not answered within the webinar, we'll be sure to get the questions, and then we can respond to them in writing. We're going to move on to our discussion panel, and would like to welcome Marcela Lopez from Water Integrity Network, who is in capacity development. Ayebale Aret, who is in borehole drilling, rehabilitation, and piped water supervision. And he's working with World Hunger Hilfe. And we also have Jennifer De France, who is a team leader for drinking water safety and quality with the World Health Organization. And welcome back again, Muti and Nick. So first, I would like to open up the questions with the panelists, with Ayebale. where you, Ayobale, have been involved in similar efforts in Uganda. Is there anything you'd like to add to what Steve has presented?
Thank you. Good afternoon, good morning, depending on wherever you are. This is Ayobale Ared. I work for WHH, a Ugandan country program. I have to thank Steve for the comprehensive and insightful presentation on bore diagnostics. And to be honest, at Verutunga Hilfe, Uganda, we see a very strong alignment between us and these methodologies that Steve has presented with our field practices. Though we have a key difference in the pump that is being used here in Uganda, we have largely Indian Mark II pump that is widely used. So the diagnostics remain the same, but somehow we have a few things that have to be changed here and there. And we are more into galvanized iron and stainless steel and PVC installation materials. So meaning when you are doing this diagnostics on an Indian Mark II pump, you have to be very careful because it's a lot of mix. However, we thank the Ministry of Water and Environment because there was a guideline that was put up on the directive on how to change or replace galvanized iron pipes with stainless steel when you are doing a rehabilitation or when you are drilling a new borehole instead of putting back the traditional galvanized iron. So all these put in place, it means when you are doing those diagnostic studies, it should be at the back of your mind that what goes back into the borehole is stainless or PVC, depending on the groundwater quality parameters, especially electrical conductivity and pH. As we move into the 9 categories Steve has presented, at WHH, we always do this, though we categorize them into 3 categories. And these 3 categories, one is needs assessment, where we go and get these communities through the districts where we intervene from, and we visit them, do a proper needs assessment, and then we go back after assessing, we know where to go. Then we do what we call a detailed technical assessment. Now this one captures everything that Steve has presented. After this detailed technical assessment, it's when now we do a rehabilitation or a repair, but they are always also categorized in 3 depending on the report. The 3 are, we shall have minor, major, and rehabilitation. So we have checklists. Each borehole will have a checklist, and you have to tick what is being assessed and the status, while making sure that you capture the history on some parameters to know what worked well previously against how it is at the current state. So with all this, I still see that this is the right track. However, like I have put it right, this is a WHH method that we follow. It may not represent the nationwide approach. So in other words, I still support Steve's way of standardizing this approach nationwide and beyond, so that the diagnostics are able to help all the communities. I thank you.
Thank you very much, Ayobale. Quickly, I'd like to move to Marcella. Marcella, you're coming from an accountability perspective. First of all, now that you've heard Steve's presentation, what do you see as the value of this type of diagnostics methodology?
Okay. Thank you, Fatah. I'm Marcela Lopez. I'm project leading at the Water Integrity Network. Before I give insights into the methodology and diagnosis, I want to give an introduction why we are talking about corruption and integrity and what does it have to do with accountability. So at the Water Integrity Network, we basically look at issues of accountability from the perspective of corruption and integrity. Why? For us, it's very important to point out that the water sector is highly vulnerable to corruption, and there are many reasons for this. The first reason is that the water sector is highly dependent of infrastructures. As we see in this case study, we need boreholes to pump water out. So, and infrastructure requires lots of money, and this makes it more vulnerable to corruption. Another issue is that the water sector is very complex, often requires many actors are involved. They have different roles and responsibilities, and these roles and responsibilities tend to overlap. This situation creates a gap where nobody is held accountable. So such complexities make the water sector, let's say, vulnerable to risk of corruption. But many things can be done. So integrity and accountability can play an important role in water provision. Some key ideas that I would like to add to the diagnosis or the methodology that I was presented is that timing is very important. In the sense, the timing of the project is very important to pay attention at the early phases of the project and identify key integrity risk and map actions to mitigate or prevent this integrity risk. In the early phases, it's very important to ask who benefits from these boreholes. Where are the boreholes being built? Or who is building them? I mean, sometimes we already mentioned that there are many institutions, organizations involved in building boreholes, but how can we keep them accountable? And how are these boreholes being financed? How can we follow the flows of money when we talk about boreholes? And this is quite difficult to follow, but it's important to trace these flows. Also, something that is very important is provide spaces for participation, access to information, and monitoring. I think we need to involve more the community in early phases of the project, in the planning, but also in the construction and monitoring and repairing phase. Regulation is very important, effective regulation. As we already mentioned, Muti mentioned that there are lots of drilling companies, but they don't have supervision. So how we can create more regulation that can keep actors accountable for and keep their responsibilities. And lastly, I would like to mention anti-corruption measures. How can we put sanctions in place when we detect acts of corruption? I think it's quite important in the whole, let's say, methodology that it was explained at the beginning. Thanks, Vatsai. I think I finished with this.
Thank you very much, Marcella. So we'll move on to Jennifer. So Jennifer, coming to us from the World Health Organization, now you have a long history of promoting sanitary inspections to check risk factors. Could you perhaps share with us how these inspections relate to what Steve has just been presenting?
Thanks so much, Vatsai, for the question, and really happy to be part of this workshop. Water safety is a critical component that should be considered within the sustainability of water supplies. And this is where sanitary inspections can be an important tool. So just as background or for more information for the participants that don't know what sanitary inspections are. So sanitary inspections promoted by WHO is a simplified risk assessment approach. So it's a tool to support identification of key risks that can contaminate a water supply. So the risks are really more focused on the water quality aspects, with a focus on the microbial safety of water, recognizing it's really the microbial safety of water that's the biggest threat, the public health threat. for drinking water quality, contributing to over 1 million deaths per year from inadequate wash, for example. So this is something that should be addressed as we look at sustainability of water services. And the diagnostic tool that was presented, it's in parts of sanitary inspections, I think, could be incorporated into the tool. So it was great to see, for example, that as one of the steps to look at possible contamination sites. And we heard about inspecting the area around 100 meters. And there's questions within the sanitary inspection tool that WHO has developed to address that question. And there's a number of other risk factors that actually should be checked when inspecting a water supply like a borehole. And we do have a sanitary inspection package for boreholes. So WHO actually published updated sanitary inspection packages last year that includes the checklist of key questions that should be considered. So I would encourage, as this guidance is being developed, to refer to the inspection tool that WHO has developed. So it's a more holistic assessment of the water supply. We need to look at the functionality, the quantity of water, as well as the quality of water. And then just another example where it was mentioned about, great that there's a step about looking at advising the community on basic operations and maintenance. And as part of the updated sanitary inspection package WHO published last year, we have a management advice sheet, which provides some basic guidance about operations and maintenance for different types of systems, small water supplies, including boreholes. There's also some guidance about monitoring schedules, what parameters to monitor, as well as if a risk factor is identified through the use of the sanitary inspection checklist, there's some guidance about how to rectify identified risk factors. And then just to flag, I heard mention about some of this can be done with M-Water, and we're in the process of developing the sanitary inspection questions within the M-Water platform. So thank you.
Thank you very much. Thank you once again, Ayabale, Jennifer, and Marcella, for coming through and giving that perspective, accountability, and the issues of managing risk in terms of microbial contamination. Now I would want to move to questions from the floor. And the very first question is directed to Steve. So over to you, Steve. What factors could cause resilting, and how can drilling contractors be held accountable for proper borehole development and casing integrity?
Sorry, just repeat the earlier part, the first part. What factors would cause?
Okay, what factors could cause this resilting, and how can drilling contractors be held accountable for proper borehole development and casing integrity?
Is it resetting, resorting?
Resilting, the silting of boreholes.
Oh, resilting, siltation, all right.
Yes.
I get it. Yeah, normally every borehole, after it has been drilled, after maybe some 2-3 years, seal to collect just at the base of the casings. And yeah, this is normal for mostly with hand pumps. This will be from dust, some debris that find its way down there. But if you suspect the siltation to be even causing the water quality, the clarity of the water, then you need to investigate further that there could be an external source directly that is actually finding its way into the borehole. It could be somewhere, some disjointed pipes, the casings where actually it could be the soil or the gravel that has fallen into the borehole. So this is where actually the diagnosis part of the borehole camera comes into play, where you actually get your camera and observe if there are any disjointed points that could indicate a point where there is a gap in the casings so that you could actually elude that siltation as a result of that breakage. But otherwise, every borehole does have accumulate of siltation, but not to significant levels that may affect the water quality as well as the depth of the borehole. But if you happen to see that depth of the borehole has been significantly altered, then that's an issue which you need really to investigate with some sort of casings disjointing. Yeah, my colleagues could actually come in. Nick, we have come across such boreholes, and decisions to make around that. They're not pretty much easier to say, well, how do you rectify if a borehole casings are disjointed? Very difficult thing to do. If it's a matter of blowing the borehole, you can blow it, you can redevelop it. But if that cases to do with the casings disjointing, that becomes really a problem, apparently.
Yeah.
Okay. Thank you very much for that, Steve. The other question that I have, maybe we can direct this to Muti. What is the cost of a single borehole diagnostic visit? So this is based on the steps that have been presented.
Yes. Okay, no, thank you for that question. And I think I just wanted to add one very important point, if it was not clear from everything that we said. If people don't remember anything from this session, remember this one thing. You must have a hydrogeologist on site when any groundwater development is happening, because these are the things that could be preempted in advance of the water supply system being handed over to communities. And again, I'm speaking from the Malawian perspective, where most wells are drilled with little to no supervision at all. So when you have the proper supervision, some of these problems like siltation, well, when the supervision is done right to ensure that the borehole design is done properly and according to the standard in the contract, then you mitigate these problems further downstream. In terms of the question put to me directly about the diagnostics, we of course we do provide it as a service, but where we have projects with partners, like for example with Stop the Rot and other stakeholders, like the work we did with Nick and the Climate Justice Water Futures Program, that is, we do not charge for that. We just cover costs. But if it is something commercial, the cost is dependent on a number of variables, like for example, distance to the location. So that matters in terms of amount of time we have to spend out in the field, and also the depth of the borehole matters, because the deeper the well, the more costly it will be to do pumping test. But just as a rough estimate, so that you know how much it costs, it's roughly about $800 per site. But that's just one site. If it turns out that you want us to come to more than one site, like 10 sites, economies of scale apply. So it will not be, if it's 10 sites, then it's 800 times 10. It will be far less because of economies of scale. So that would be my response to that question. Thank you.
Thank you, Muti. A question for Ayabale. So can the diagnostics be done on non-functional or only functional boreholes?
Thank you very much. Diagnostics can be done on boreholes that are functioning with difficulties or boreholes that are non-functional. When always it's spotted that a borehole is functioning with the difficulties, it has to be investigated. The non-functional automatically they qualify without a lot of science. Yeah, sure.
Okay.
Fadzai, if I could just add to Ayabale's point, precisely right. The point of the diagnostics is to figure out why is it failing. So that means it can be used on a site that's working as well, if you just want to check that everything's fine. But the purpose of the diagnostics is to check why is something failing. Why is a hand pump not working? Going back to something that Nick said a little earlier, in Malawi, we put the blame on communities for failing to manage, to repair and maintain their water points, when actually the problem could be something far more technical that is beyond their control. So the diagnostics approach helps determine that, to figure out what is causing the problem. Ayabale said maybe a hand pump is actually really difficult to operate. And in some cases, the hand pump has completely failed and has not been used for years. So you can actually use it on any of those to determine the cause of failure, where failure is there, or to preempt failure where possible. Of course, depending on the particular problem you're looking at. Yeah.
Right. Thank you for that further clarity, Muti. So a question for Marcella. How can this powerful tool for the sustainability of wash services in rural areas and developing countries be effectively integrated into a country's policy framework? Sorry, Marcella, you're on mute.
Yes. I think something very important to do is to bring these, let's say, policies and norms very clear and embedded in the regulators. I think regulation is very important in this field. As you already mentioned, Muti, there is no supervision, no clear roles and responsibilities, no guidelines. Drilling companies come and then basically nobody supervise their work. And I think regulation can be very important to make clear roles and responsibilities so that communities can hold them accountable. So a clear regulatory framework definitely can help a lot.
Thank you very much for that. And the next question is for Jennifer. How does water quality surveillance testing fit into the diagnostic, and who should pay for the water quality testing?
Thanks for the question. So water quality testing, as we heard from Steve's presentation, should be part of the diagnosis, and it's a key surveillance activity. And for us, surveillance actually means the water quality testing, assessment of risk management practices, so auditing water safety plans or conducting sanitary inspections. Surveillance is an activity to be conducted by the regulatory authority. So that complements the activities to be done by the water supplier. Regarding who to pay for testing, I think it depends on the context. And it also impacts like the frequency of testing. So for example, for many community managed supplies, often the communities cannot pay for the testing and the government will pay. But in that case, then the testing is very infrequent. And in such situations, it's really important that the testing that's conducted informs wider programming, particularly when there's lots of supplies, you can only test some supplies each year. So it's really important that it informs wider programming. And then sorry, because I forgot to mention this last time, if I can just add one other point. The sanitary inspections I mentioned before, I think it's a nice complement to the water quality testing, whether it's done as part of the diagnostic activity that Steve was talking about or by someone else, in that when you get water quality test results, that doesn't tell you what the problem was, right? How to fix that problem. And that's where sanitary inspections can come in to identify what are the risk factors that should be addressed. That points to where action should be taken to address the water quality issues. So thank you.
Thank you, Jennifer. And a question for Nick. If we get a borehole with a yield of less than 0.25 liters per second, maybe something like 0.1 liters per second, and with high water level table, is it necessary to install a pump?
Well, yeah, I mean, that's a good question. I think the AfriDev and I think the Indian Mark II pumps are designed for an output of around 1,000 liters an hour, which is about 0.25 liters a second. So that's the sort of target yield, I guess. However, I'm aware that in many cases, particularly in very, say, hard rock geological environments, there's often not a lot of water available, and yields of over 0.25 liters a second are not easy to get. So in cases where there's limited water availability, I'm aware that the best option is to, if you can achieve 0.1 litres a second or something like that, that would warrant a hand pump installation, because that's probably on the higher end of the yields that you're going to be getting. However, if you were in an area where you thought that there should be more groundwater available and typical yields might be 0.5 litres a second or above, and you were getting 0.1 litres per second, you would maybe look at that and think, well, this is going to limit the output of the hand pump.
Yeah.
So it's probably best to try and drill a borehole that had a high yield, which was going to likely be more sustainable in the long term. This goes back to what Muti was saying about sort of, I guess, the sort of good technical planning and oversight of the whole process, and also links into, there will be in a lot of countries specific government rules and regulations dictating what the yield of the borehole should be. So yeah, I think it's difficult to say. It depends on the area.
Yeah.
0.1 litres a second in some areas where there's very limited water availability is really, really important and really, really, really valuable. However, in other cases, it may well be actually quite on the low end of what should be achieved.
Yeah. If I could also complement what Nick has said, we've had situations like this before in our work. And it's quite heartbreaking. You go to areas where you've drilled 3 or 4 times and you are just not finding, 0.25 liters per second. And I think when we have had those situations, what we've had to do is we've engaged the community and we've engaged the client and we've said, these are the options in front of us, and kind of do an options analysis, a kind of trade-off analysis with the community there to understand what the options are. And sometimes it's really difficult to find the best option. You kind of have to see how you can work within what's available. And I think in addition to that, I mean, one particular example I can give of an experience we had recently is there are some locations where the water is not, it's salty. There's just salty water in that area. No matter how deep you go, it's just salty. And we were given an assignment where we had to drill in this area. And I remember, Steve will remember, we actually were like, it's a waste of money drilling in that area. We know the aquifer is salty in that area. So we tried to look for other options. And the best option was connecting the community to a water supply, a piped water supply system that was managed by a public utility. Now, we are a groundwater organization, but we actually said we'll tap into the best option that's there. And the best option that's there was connecting to a pipe system. Now, there are trade-offs with that, because then they have to pay the tariff as and when it's required, as compared with a point source where they have the option of, skipping a couple of months not paying. So there are trade-offs there. So I just wanted to complement what Nick was saying, is that it's quite heartbreaking when we can't find the required standard, but you need to have a kind of options conversation with your client and the community so that they understand the situation and the options that are in front of us, and then make a decision based on the local reality.
Thank you very much. So there was mention of different materials. A question here for Ayavale. Are there any insights on replacement of GI pipes with UPVC pipes in hand pumps?
Yeah, sure. Thank you very much for the question. Indeed, we cannot miss the use of UPVC pipes in borehole construction, mostly for hand pump parts. And our context here in Uganda is that usually we look at the ambient conditions of the water, especially when you are drilling or rehabilitating during borehole flushing. When water clears, you have to have at least a pH and EC meters at the site so that you are able to get the ambient conditions of the aquifers. So you have to test the pH right away and the electrical conductivity. So this will guide. When you find that the pH is below maybe 6 and the EC is going above 500, 600, 1000, then you know that the water may be so aggressive. Even when you put stainless steel, you may have a couple of issues building up. So usually use that tool to already recommend the use of UPVC. To some extent, also get limited with the depth, mostly if you are using threaded UPVC, because usually install not more than 30 meters. Because if it's just threaded UPVC, the tensile strength of the threads usually may not be able to hold the whole string going maybe to 45 meters. So the ambient conditions of the water should also be coupled with the final dynamic water level during pumping tests, so that you are able to be guided on the depth or with the other parameters. I thank you.
Thank you, Ayobale. So our next question is directed to Steve. Can you provide more details on the verticality testing, how it works, and the equipment that would be required, and rough estimate of the costs?
All right. Thanks for that question. Borehole verticality, as I explained earlier, we're trying to check if the borehole, the hole, is perpendicular enough that it could allow the parts, the pump parts, to operate freely without rubbing the walls of the casings or the rising main pipes. You could use a number of tools available on the market. The sophisticated ones are obviously very expensive. During the time we had the Water Futures, Climate Justice Water Futures project, we had a deviation tool, which was quite expensive. It was reported that it was around 5,000 pounds, and we used that under that project. But there are other cheaper ones, inclinators, which could be I think got from any shop, hardware shops. In civil construction, they use these inclinators just to check the straightness or perpendicularness of possibly a high or tall infrastructure. So these ones could be found available in local hardware shops. But one which I had experience with the project that we had was quite an expensive one. It was a deviation tool that really gave us very good data precisely. What I would also indicate is that perhaps the remedy to deviation is very limited. When you find that a borehole is not straight, it doesn't really inform much what are you going to do. You will not be able to correct that. It's something that informs almost at the level of policy or operations in terms of drilling, to enhance the standards that when you are drilling boreholes, we have to ensure that straightness is achieved during the drilling. So mostly you should consider a strategy of how are we supervising the drilling so that we don't end up with boreholes that are not straight. Thank you.
Thank you, Steve. One of the statements that have stuck with me is that excellence starts before the first turn of the bit. So I think that's one of the things that we also need to make sure we consider. So a question for you, Nick. We are moving on to motorized systems, and so some of the work is now around motorized systems. So the question is, how can the diagnostic method be adapted and used for such systems?
Yeah, that's a good question, because the work that Steve's been sort of referring to here is focused on hand pumps only, mainly because in Malawi, especially when the work was sort of started quite a number of years ago, there were very few motorized pumps in our operation, and the ones that were are typically in private enterprises and properties, and there were very few motorized pumps serving sort of general communities. So this was focused more on hand pumps. However, obviously, yeah, it is obviously in many parts of the world, especially other countries, there's much more motorized pumping. And I think I've used this technique and similar techniques to do borehole performance assessments in the UK and other countries where motorized pumps are found almost everywhere. And it essentially boils down to the same general principles of looking at the pump first. Is it operating within the sort of design conditions? Is it operating correctly? Is it in good condition? Then you can look at the borehole and understand the borehole construction, and the borehole camera survey and everything is the same technique. And the assessment of the groundwater resource and water quality as a whole, obviously the same principles exist there. It's just a different pump that's being used. So I think it can be easily adapted. I think Donald John has been saying in the chat that BGS and other organizations are looking to standardize, publish standard guidelines on testing and assessments. So I assume that would be part of it. I don't know, so maybe we can clarify that afterwards. But I think what Steve talked about here, the general principles can easily be carried across to motorized pumping setups. And the yields and the amount of water abstracted are going to be much higher. So there's probably a need to have a much closer look at the aquifer performance and the borehole performance through longer pumping tests and further assessments. But apart from that, the general principles are all basically the same.
Mm.
Thank you very much for that, Nick. I understand to our participants that we still have quite a number of questions that have not been answered. Due to our time, we'll not be able to continue to answer questions, but we'll strive and do our best to respond to you even after the webinar. Now we're going to move on to a round of closing remarks from our presenters. So you have just a minute to give us your final thoughts and final insights around the matter of diagnostics and accountability. And so we're going to start from Nick. We go to Jennifer, Steve, Marcella, Ayabale, and finally Muti. So just 1 minute, our presenters, with your final thoughts. Over to you, Nick.
Yeah, thanks for that. So thanks everyone for attending, and thanks, Steve. That was a really good presentation that was done. It's really good to see that this work continued in Malawi after it was started quite a long time ago. And yeah, I mean, final comments would be reiterating what I've just said. I'm a hydrogeologist, so I'm particularly interested in the the groundwater resource and borehole construction and groundwater abstraction. So I usually am trying to convince people or implore people to consider the abstraction point as a whole, which involves the water resource and a borehole and a pump together, which is the best way to look at things to really understand what's going on and strive for sort of sustainable abstraction and use of the resource. And yeah, the accountability aspects, I think we're gathering data and providing that to stakeholders, which go on to have the lively debates like I was referring to with Muti there. So it's good to see that this is primary data is useful and is triggering important conversations. So thanks for that.
Jennifer?
Thank you. And really, really interesting webinar and great presentations. And the one point I just want to highlight is I really appreciate that the regulations and the role of regulations it was highlighted here. For the work from WHO's side, we've really been highlighting the importance of regulation to move towards professionalized service delivery, the links with accountability. So it's really terrific that that was raised. And just to flag that we're publishing next month a call to action to really raise the profile of regulations. This is for regulators and to call to action to really strengthen regulations for water service delivery. And I think the Water Integrity Network, other partners are involved in this effort, and that's going to be launched next month. Thank you.
Thank you. Steve?
Thank you very much, everyone, for participating in this webinar. It has really turned out great because of your participation. And moving forward, we see ourselves already challenged. When I looked into the Q&A box, there are quite so many questions which reflect that the different contexts in terms of the issues that we are meeting on the ground in borehole construction, as well as operations and maintenance. So we haven't really exhausted the procedures, the diagnostic steps, literally. But as Nick said, I think the principles align into how we can apply them in different aspects and contexts. So thank you so much for these great questions. We'll be reflecting upon them and see how we actually include some of these into the diagnostic steps so that we really comprehensively cover these issues. Otherwise, at this juncture, I may hand over to Fadzai. Thank you.
Thank you, Steve. We move to Marcella.
Yeah, there is a point that I would like to highlight again, the issue of regulation. I think this is a good way to strengthen accountability and integrity. There are so many actors involved in construction of boreholes, as we already saw today, and we need clear regulations to keep them accountable.
Thank you, Marcella. Over to Ayavale.
Thank you, everybody, for the attendance today. This has been a great meeting. Just one word to our people who have attended is that while we are looking at the diagnostics of the already existing infrastructure, we can still reverse it for the infrastructure that is to be put in place and start the processes while looking at quality, accountability, and transparency to avoid solving the problem when it could have been solved before it started. I thank you. Yeah.
Thank you, Ayavale. And last but not least, we'll have our final words from Muti.
Thank you very much. Jennifer and Marcella have stolen my thunder because I wanted to talk about regulation. But I think maybe before I say that, I think just as a note to everybody, we, as an organization, as Steve has said, we are open to evolving and trying to look at how we can make the diagnostics process better. So please reach out and for collaboration where possible. Actually, we are in a process of putting all our data online so that people can actually see our data, critique our data, as well as validating our methodology and making us accountable to you. So this is something that we'll be doing and sharing through RWSN in due course and other platforms so that it can be a collaborative effort. But I just last point I want to say to that is that one thing I've learned from this process, particularly the accountability piece, is that people will not regulate themselves. People will not do good because it's good to do good. Unfortunately, you need regulation, and you need tough regulation to ensure that has happened. That's the one thing that I've learned from this experience, which is why as an organization, in addition to the diagnostics, we are looking at working with the regulator in Malawi to see if we can have a water tribunal, because we are not going to regulate ourselves. Local governments, NGOs, faith-based organizations are not going to do it by themselves. You need another entity to do that, and that's where the regulation comes in, and that's where we're focusing our energies right now. So regulation, really important. Thank you.
Thank you once again, our facilitators, our participants. Thank you for sharing your insights and your experiences in this work. It's such a great work that you are doing. And so one of the things that I've also learned is that there's a famous statement that says you can't expect what you did not inspect. So just to emphasize that, yes, just as Muti has said, we need regulations so that we'll be able to expect what has been inspected. And one last thing I would also want to say is that to pick out the importance of community engagement in the part of diagnosis. At the end of the day, they are the ones who are affected by a dysfunctional water point. And so the water source that is being dismantled needs to have also the buy-in of the communities as we do this work so that they can plan for a time that they are not going to have a water source in the case that it was partially dysfunctional. So thank you very much all for your wonderful insights, and would like to also take this opportunity to thank our participants who've been with us and who have been engaged in this webinar. We can see with the number of questions that we actually have not been able to exhaust, but we are sure to take note of those, and those will be used for the work going forward. Now we want to also thank the funders of this webinar. Thank you so much for supporting the webinar. And please join us for the rest of the webinars that are lined up. The next webinar is sharing lessons from the Nepal MUS network, the multi-use water services. So please be sure to join us for other webinars that are upcoming. Thank you from all of us, and thank you to the participants and the audience. Have a great morning, day, or evening, depending on where you are. Goodbye.